Hello and welcome to this short video, and what we're going to do in here is we're going to look at the action of a capacitor, that one there, the rather hefty looking thing, 470 microfarads, and it's going to charge through a 330k resistor and discharge itself through a 22k resistor into a red LED. I've also hooked the thing up to a couple of meters. One's a multimeter, which is going to show us the voltage, and as you can see there's a bit of residual charge in that capacitor. We've got 0.04 volts there. There's nothing to worry about at all. And the other one's an oscilloscope. The oscilloscope showing 0 volts as it would do, and we're going to switch on a 9 volt power supply, and when I do switch it on you'll notice that the LED won't come on straight away. So let's switch the thing on. There it goes. Look at what's happening here to the multimeter. The voltage is going up very steadily, and what's happening is that the capacitor is taking on a charge. And what's happening to the LED? It'll take a while for you to see it in this film, but it should be getting brighter round about now, because the voltage is 1.6, and there we go. Okay, and it'll keep getting brighter until the voltage gets up to a little over 2 volts, because it's a red LED and that's all it needs to shine. So where are we now? 2.06, and the oscilloscope's saying the same thing. I'm going to switch this off now, and you'll see that the LED immediately begins to dim, but it doesn't go straight off. If we look at the meters, okay, that's still showing there's quite some charge left in there, and that's showing there's 1.65 volts. The LED's dimming. Now the 22k resistor is resisting the flow of electrons. That's its job. Okay. So, and resisting the flow of electrons, it's letting the capacitor discharge at a steady rate, and there goes the oscilloscope showing us that the voltage is going down. Okay, and the rate at which the voltage is going down is steadily decreasing. Went down quite fast to begin with, and now it's going down a little bit slower. This is the action of a capacitor. What it does in a DC circuit is it charges, and then it can discharge. It'll charge up to about 66% of its capacity in a time period, and then the remaining 33% it'll charge up to the 66% of that remaining 33%, and then the remaining 33% of that 66%, and so on. A capacitor will never ever fully charge. It can't do. It'll get up to 99.9, but it'll never charge to 100% of its actual value. That's a capacitor in a DC circuit. Impedance in a DC circuit is mainly controlled by resistors. The reason for that is that there isn't much frequency in a DC circuit. It's one steady voltage all the time. In an AC circuit, capacitors behave quite differently, and that's what we'll look at in the rest of this article.